Good morning. I am very happy to be able to open the second day of Takeovers. My name is Sangwook and I'm in charge of authentication and account development at Line Plus. Today I'm going to talk about some of the feature developments regarding Line account transfer. Let me first talk about the agenda of my presentation. I'll talk about the background and then the challenges of line account transfer and two improvements that we have made to resolve these issues. First is biometric authentication for easy transfer, and secondly, letter sealing key transfer via secure backup. For letter sealing, I will talk about the letter sealing more in the background portion of my presentation, and then I'll move on to the summary and upcoming plans. First of all, let me touch upon the background. Not just the server developers, but all line developers are making a lot of effort to provide the most convenient features to the users and also very safe features as well. And it is very important for us to strike a balance between security and user experience because both of them are for the users. We cannot choose one out of the two. So the improvements that we have made is to increase the security and also user convenience. Let me talk a little bit about line account transfer. When the user buys a new smartphone, we have to make them go through authentication and account identification when they get a new phone and transfer their line account. So because in line account, it only allows the use of one smartphone. And during the line account transfer, there can be many ways using phone number or password. However, there are limitations in user authentication and identification. As you may know, the phone number can be transferred to another user, so it is very difficult to identify the user. And for password and PIN, the authentication can be done using these values, but the user can forget or it can also be exposed. And when it is also difficult for the user to use a very secure and safe password. Next is the line letter sealing. And this is the end-to-end description because because encryption is done based on the security key. All the messages will not be exposed and the client's key cryptography is used. In other words, elliptic curve cryptography is used to share the secret key, and the public key and the private key will be generated as a key pair, and the public key is shared through the server. Private key in the case of private key, at the client level, it cannot be confirmed, so it will not be, the shared secret will not be exposed. Now, let me talk a little bit about the challenges. I would like to talk about three challenges. The transfer must be easy for the users and it must be able to prevent takeovers, and it also needs to secure seamless transfer of chat history. Let me talk about the three elements one by one. As I have already mentioned, the authentication features based on the user memory can be weak and it could be vulnerable to phishing attacks. And so in order to prevent these from happening, we ask for another level of authentication. So, but then this will elongate the authentication level and it makes it difficult for the user to complete the transfer process. 30% of the users who call the call center have questions regarding account transfer. So we have been looking for improvement measures. I've talked about the phishing attack. The phishing attack and takeover from phishing can lead to data exposure and also monetary loss as well. So it can have a very big impact. So as you can see here, the attackers create a UI webpage that is very similar to Line, and they ask for the passwords. And it's very difficult for us to deal with this. But in order to prevent user damage, we have a process where we can request a site stop when we identify the phishing site. I have provided the site link and the technology blog, so please refer to them later. And thirdly, the users want seamless transfer of their chat history, and what is difficult here is they don't want to look at the chat history, but also the letter sealing keys must be transferred as well. So before adopting this feature, we have used the external cloud service to restore the chat history and backup. However, this inevitably makes it very it has to rely on the platform backup and restoring that is not provided. So that out of let me talk about some of the advantages of the new features of account transfer. First is biometric authentication. Face recognition and fingerprint recognition are some of the biometric authentication that we're familiar with, and it's not based on information that the user knows, and it is more secure, and it provides authentication using the devices that use line, so it is easier to identify the accounts. So to unlock the key store of the device where line is used, we have applied biometric authentication. And although this is not applied in the current feature, we can also support a FIDO2 spec-based device biometric authentication. We have provided the link and also the presentations regarding this technology, so please refer to them later. Now let me talk about easier account transfer using biometric authentication. So basically, this is when the user has an existing device or current device. The user has two devices, the current device and the new device where the transfer should be done to. So first, the QR code is generated in the current device. In the new device, the QR code will be scanned, and to receive the data from the current device, it sends a request to the server and waits for the response. And a confirmation request is sent in the current device to identify whether the user has actually asked for account transfer. And the biometric authentication is done to have access to the key store. And a secret key is used to encrypt the data and sends the contents to the server. And so the letter sealed key can be transferred to the new device. So it is difficult to understand the user experience looking at a drawing like this. So these are some of the screens that I have provided to you to make you understand the user experience. So the left-hand side is the current device and right-hand side is the new device. So in the new device, biometric authentication-based account transfer will start. So the user will access the setting page of the current device, and in the new device with the camera, QR code will be scanned, and the existing device will confirm that account transfer is being done, and then biometric authentication, and then the whole process is complete. So the strength of this kind of feature is simple and it is very intuitive. It does not rely on the information in the user's memory, and end-to-end encryption allows transfer of letter sealing key. And the most important part of the third strength is that the letter sealing key can be transferred. End-to-end encryption, sending letter sealing key is a very important part of this technology, and I would like to delve into more details. So in the letter sealing key, there is the device data that includes a letter sealing key. And then there is the public key, private key pair that is generated, and nonce value will be generated as well. And in the current device, QR code is generated, and the public key and the nonce value is included in the QR code. In the new device, the public key, private key pair is generated, and when the QR code is scanned, the current device public key and the nonce will be transferred to the new device. And the new device can have the shared secret key for double encryption. And the new device sends the public key and the nonce value.
And sends the information to the current device, and the nonce value is matched. Whether the nonce value is matched is identified because the new device receives the public key, and the current key can create the secret key for data encryption, and the data encryption is sent to the server, and the secret key is encrypted, so the letter sealing key cannot be known, and the server sends the encrypted information to the new device, and the new device decrypt the data to the shared secret key, and the decrypted data is stored in the new device, and the letter sealing key transfer is completed. So I have explained about the account transfer when you have an existing device. And now I would like to explain about the account transfer without the current device. In other words, transferring letter sealing key under this condition. There are often cases where the users loses or breaks their devices, and I have mentioned before that the letter sealing key is stored only on devices. So in order to transfer the keys to the new devices, first we needed functions to backup and restore keys. The server must not know the raw key value under any circumstances. So we try to find out how to backup and restore letter sealing key safely. So I have explained about this during the 2019 Line Developer Day session. So I would like to touch upon that briefly. For letter sealing key backup, many authentication methods have been dealt with. And we could think about backup and restoration of a key without any encryption. So this will be the most easiest way. However, the key is exposed to the server in text, so this is not an option for us. A randomly generated password with high entropy could also be considered. In this way, the key value can be protected most safely. However, this uses very long passwords, so this is not a feasible option for the users. So considering to balance between the good user experience and high security methods, we try to use the PIN code as an authentication method for backup and restoration of keys. So the key backup and restoration using PIN will be following the same mechanism for smartphone lock screen and OTP card PIN. To prevent guessing the PINs, we put a limit on reattempts, and under hardware-based safe execution environment, the attempt count will be counted, so the attackers cannot manipulate the counts. And if the attempt goes beyond this limit, then the chat history cannot be restored. So we have implemented this approach in two ways. First, we try to create a trusted execution environment for key backup and restoration. This is important for preventing manipulation or exposure. The concrete details have been explained in yesterday's session. We have explained about the trusted execution environment and the characteristics of this environment. Second is about enforcing limits to restoration attempts to prevent brute force attacks on pins. Not only attempts in line client, but also attempts in company network have been dealt with. We versioned the backup state and stored the restoration attempt count. And I would like to focus on the second part. Now, this shows how letter sealing key is backed up, and restored. Here, public key and private key refers to the encryption key used for encryption and decryption in a trusted execution environment, or TEE. As I have mentioned, TEE is implemented in the server instance, so it has enough space. It doesn't have enough space to store the key backup of all users. The backup is stored in the persistent storage, and the backup and attempt count is encrypted and sealed in the TEE and is stored in the persistent storage. So if the TEE is not processed, then the key cannot be restored, and the attempt count cannot be modified. So this is a picture similar to the TEE. I think you have seen this picture from yesterday's TEE session. The backup data is encrypted using public key and PIN code, and it goes through the internet and company network to be forwarded to the TEE. And the data are encrypted. And let's come back to that simple model. I would like to explain key backup and decryption method. First, the client makes a request for backup and restoration. Then the backup and attempt counts are sealed, and the stored data is retrieved from the persistent storage. And the sealed data is forwarded to TEE. And when the conditions are met, then the data will be processed. And I would like to talk about this part in detail. Depending on the matching of the PIN, the attempt account is updated, and the result is encrypted, sealed, and encrypted. And the sealed data is updated in the persistent storage, and the decrypted key is returned to the user. The returned information is not the key data itself. It is the encrypted data that can retrieve key data through decryption in the client. I have mentioned the key data restoration process. I would like to talk about the conditions for that. Here we compare the attempt count from the persistent storage and the attempt counts from the TEE. If the attempt count from the storage is the same or larger than the attempt count of the TEE, then the process goes through. And this condition is important for preventing reattempt attacks on the network. So this is the structure that responds to the key attack scenarios. If the client tries to find out the PIN in the the PIN, then when the PIN is wrong, then the attempt count increases. When the attempt count hits the limit, it is permanently blocked. If the attacker in the company network replace previous requests to find out the PIN, then the sealed data from previous restoration request is given to the TEE. And then the attempt counts from the previous request is smaller than the attempt count from the previous process. So the replay attack will fail as it does not meet the attempt count condition. So I think that we can face two issues under this structure. First is enhancing the access control and monitoring in extended storage. This is related to the current function and also the server environment as a whole. So I think we will have another opportunity to introduce that. Today, we are going to focus on the mismatch in attempt counts. So in order to introduce our alternatives to tackle the inconsistency, we have created a structure that closely resembles the current TEE. As I have mentioned, the TEE is installed inside the environment server instances, and the attempt count in each environment exists separately and are not shared. And the attempt count in this attempt count in the same account is restricted within the single and the same safety environment. So the server instance is decided depending on the user ID. Now I'd like to talk about the inconsistency in the attempt count. And the attempt count in the persistent storage is using the reference count for limiting attempts. And the attempt count and the backup information has to be sealed and stored in the persistent storage. And if there is a failure, then there will be mismatches between the two. So as you can see from the right-hand side, the attempt count in the TEE has been updated in the second stage, but if there is a failure in the phase where the repository is reflected, then the attempt count will face a mismatch. So we have to come up with an alternative because we need to reduce a bad user experience. So let's talk about the situation where the user makes an attempt to restore when there is a mismatch. The attempt count in the persistent storage is lower than the attempt count in the TEE, and this goes against the conditions. So the process is rejected. And even if the PIN is correctly entered, there is a failure in restoration. So we have come up with two alternatives. First, the mismatch occurs because of the failure in the storage phase. So there is a retry, and retries are allowed until storage update succeeds. And that was possible thanks to the large Kafka cluster and streaming task process framework called Decathlon. And when the storage is successful, then the mismatch will not happen. So the correct PIN will not cause any failure. However, this will not completely exclude such events. The second is to make a retry in TEE when there is a mismatch and a failure. So when the user makes another attempt with the right PIN, and when there is a request that had been rejected because of the mismatch, then the routing strategy changes from sticky strategy to round robin. The retry will send to the TEE, and there is no limit for retries, so the count starts from scratch. So the restoration begins with the attempt count matched, so the user experience can be enhanced. So, however, it follows the calculation based on the TEE count, and it will be able to prevent brute force attack. Last but not least, I'd like to summarize today's presentation and talk about future plans. In today's presentation, I have introduced the 3 challenges of line account transfer feature, and there have been 2 improvements that we have adopted. First is about new transfer flow based on biometric authentication for device on-hand case, and the other is new letter sealing key transfer function for device not on-hand case. And I'd like to introduce our future plans. First, it's about creating new account transfer feature to protect against phishing even when user doesn't have the previous device. And second is to create better user experience using biometric authentication across our features, applying Line client's biometric authentication to Line login for third parties. And third is to provide broader coverage of message backup and restoration feature by supporting cross-platform cloud-based chat backup. The cloud-based backup server can restore deleted chat history, which is an advantage. It can be used together with the server-based backup. So we are going to try to back up and restore chat history based on cloud across different platforms. And last but not least, we have introduced the improvements, which is the result of 2 key projects: software development, planning, security, UI, UX, and QA teams have participated and contributed. And As a person who have contributed also, I'm very happy that I could introduce our efforts to create easier functions and better security methods. So I hope that we could provide better outcomes by continued efforts. I hope that we could introduce the outcomes through the next Tech First presentations. With this, I would like to conclude my presentation.
Thank you very much for your presentation. We're now going to begin the Plus Talk. If you have any questions, please use this opportunity to ask questions. We're going to receive questions from you as well. So on your right, on the bottom of your screen, right hand side, you can ask questions. Kudahayashi Masahiro from Yahoo Japan is going to lead this Q&A. Good morning. I am Kurahayashi from Yahoo Japan. I am going to host a Q&A session for the Plus Talk. As you may know, LINE and Yahoo Japan is integrating the management, and we are implementing many projects, and we're actually working on an ID account project together. So if we can go back to the title slide. Thank you very much. Please continue. I'm going to ask you a question. First of all, encryption, to encrypt. The key, I have a question regarding encryption key. In 2015, around 2016, in LINE application, we have done end-to-end encryption. And in the talk screen, there was a key icon. I remember the key and lock. So it means that our chat is being protected. LINE is very serious about protecting privacy and security. And to improve security, LINE is working very hard. And I think this is a great thing. So I would like to move on to the question then. In the encryption of talk, the algorithm change or the key rotation, can you respond to these changes? First of all, let me talk a little bit about rotation. The feature that I've introduced to you is to transfer the key from the current device to the new device, but on a different note, when there is a new device, a new key can be generated. So key transfer is to check the existing chat history. So key rotation is allows generation of new letter sealing when a new device is used. And for algorithm renewal, letter sealing key, well, the letter sealing feature or the method, there are different versions. If you look at the white paper, you'll be able to see that the current letter sealing version is V2. And internally, we are trying to improve the letter sealing. So please refer to the letter sealing white paper to see what kind of different algorithms are used for each version.
Thank you. So the security developers do not believe that encryption alone is not enough. Key rotation is also needed, and encryption algorithm is necessary for each case. Now, the letter sealing key also incorporates this idea. That's how I understand. Thank you very much. Next question. Transferring the account. I have a question on account transfer. In providing service, account transfer is very important. And when there is a big change in device data, then we have to consider many things. When supplying Android or Apple devices, and if you are changing from Android to Apple or from Apple to Android, then we need to make a lot of changes. So cross-device account transfer function is necessary. So one might simply think that you just need to log into the new device. But as you have mentioned in your presentation, even if using one-time password, it will be exposed to phishing attacks. And using phone numbers will not be safe because the phone number is mutable. So password SMS will not be enough, so account transfer will rely on many other things to make it safer. So about account transfer. So is this account transfer stack developed by Line developers in-house, or have you also considered other competitions technology as well to come up with this result? So in short, we have adopted both approaches. We have biometric authentication, and this has been customized to our server environment. We have used the QR code to transfer the public key, and that's one example. But we cannot say that we have invented this idea because other services, other competitions are also working on this. We have referred to the messenger services across the world, not only from Japan. So we have tried to find out how they work, and we try to learn from some cases to design our service.
Thank you very much. We have a question coming in at the chat window. So the account transfer using QR code, you use biometric authentication for transfer as well, according to your presentation. So this is a local biometric authentication? That was the question. Yes, we use the device local biometric authentication. It is linked to our well, we can make the user use the biometric information in our service, but only those who have provided the biometric information to our service can use the service. We want to make users as more users use this service, as many as possible. So that is why we have allowed them to use the device biometric information. Thank you very much. As you've mentioned, when you use the FIDO system, the key information can be used for authentication. So that is the impression that I had. And so when you have the current device and the new device, and if you want to transfer the current device information, you can use that information for authentication and then transfer. So if the old device that is not FIDO is not signed up for FIDO, it can limit the convenience of the user. So that's my understanding, that the local authentication information is used.
And about transfer. So we use the local bio authentication to make use of the QR code. That's the current state. Maybe we could make it simpler going forward. Are you having that in mind as well? So we use the biometric authentication. The current method is about recognizing the device ownership. And this is the safest and the surest authentication method. But if we authenticate with PIN code, then it will be exposed to phishing attacks. So there will be more vulnerability. But if we adopt the biometric authentication, then it means that we are going to adopt a more safer authentication method. But I have already mentioned in the future plan that the authentication without having a device nearby will not have that strong authentication strength. So we have to come up with alternatives.
Thank you very much. The users, it is important to prevent the users from experiencing any surprises or inconvenience. So I would like to ask you for further efforts. Well, because we don't have infinite time, there are some additional questions, but I think I will give you an opportunity to use this time to talk to the developers about the security and the user experience of accounts. If you can give the developers a word of wisdom, so some points that the developers should focus on. Well, although this is a server session, as I have mentioned in my presentation, this is a result of a collaboration from all different aspects. So the security development team for security, UI UX design planning team have done a lot of work for user experience. And so the developers, in order to generate the best synergy, it is important to listen to the voices of the professionals and try and find out how best to execute the project. So if we put our focus on these areas, I think for any account or any domain, we'll be able to develop by maximizing security and also providing best user experience.
Thank you very much. I am actually working with Mr. Sangwook together in the team about this line project. It was the first time that I have learned about this. Yahoo Japan is also trying to bring more convenience in our service. So I would like to cooperate further. Well, thank you for your presentation.